Hello, my name is Mike Iguchi, and I'm an engineer here at ImageCat who is involved with the development of the exposure database for the METEOR project. In this presentation, I'll introduce the basics of exposure development. I'll go over the heuristic evaluations of construction patterns for generating a level 1 exposure database. Such topics will include identifying sources for categorization of structural types and materials, mapping to a given building taxonomy, and ultimately creation of the mapping schemes for level 1 exposure. So exposure development first begins with identifying the local materials and structural systems common for the region. Construction practices will vary from country to country for a number of reasons, either availability of materials, variations in traditional construction techniques, development and enforcement, or lack of a national building code, amongst other things. The slide identifies a few of the main categories as well as some examples of sources that should be checked for this process. The availability of these sources will vary per country and will often require some basic knowledge of materials and engineering topics. So we typically first do a literature review to pull any existing documents on country-specific and structural-specific construction practices. These types of reports will not be available for every unique structural type within the country. However, for those that are available, they do provide some very valuable insight. Such sources include EERI, World Housing Encyclopedia, Pager, GEM, etc. Google Scholar can be helpful for looking up in these situations. These reports are generally very detailed and will often identify where in the country the structural type is found, typical height profiles, structural systems for both lateral and gravity loads, foundations, common deficiencies, and other building attributes. The one downside is that these reports are often limited and they lack the diversity of structural types and geographic regions. We then look for any country-specific statistics. We've identified that most countries have a publicly available census and housing data that can be sourced. We found the most useful part of this data are the regional breakouts of wall, roof, and flooring materials. Most of the time, these are broken out into rural and urban regions. However, we've seen a few countries publish the statistics at a finer resolution. While specifics regarding the lateral system are not included, understanding what materials are being used and in what region will allow us to infer the structural system based on our previous research and observations. This type of data is useful for preliminary development of mapping schemes and general quality control checks. National building codes may or may not be available for each country. If they are available, it can be used to determine the country-specific construction practices, materials, detailing, and other structural requirements for code-compliant design. Interpreting the code to determine buildings' strength, ductility, stiffness, deficiencies, and other things will require some technical and engineering background. One main issue is that even with an established building code adopted, construction can often be unregulated, and what's proposed in the code will often not be found in the field. So one should be a bit wary of automatically assigning a vulnerability to a specified structural type. General code compliance and adoption should be researched beforehand. So user-submitted and online imagery are the most common types of information available for exposure development. Street view imagery through sources such as Google, Mapillary, online videos, and geotag photos allow us to visually identify the building attributes such as number of stories, occupancy, structural systems in some cases. Using street view and satellite imagery also allows us to identify general correlations between roof shapes, gable or hip, roofing materials, see tiles, built-up thatch, and wall materials. So where street view is not available, particularly in rural regions, these correlations will be very useful in inferring a structural system. Occasionally, a building under construction will be visible via ground imagery, which can help determine the lateral system involved. Submitted photos or videos often give an interior view and will reveal some information not visible behind the exterior facade. Post-disaster photos or videos will often reveal exposed building materials and failed structural systems. A number of online imagery sources can be helpful with structural designation determinations. So the previous sources should give the analyst a general understanding of the types of structural materials used, types of roofing materials used, and types of structural systems that are applicable to a given country. Next step is to find the distribution of construction types based on the built-up development patterns. The table here provides a sample of the structural distributions for rural regions, and are categorized for the pager taxonomy. These can be mapped to other taxonomies, such as GEM when required. So this slide and the following ones will give a general summary of how to determine the country-specific construction types and the structure distributions for any given country. For this one, we used Bangladesh as an example. So the first step is to do, as previously mentioned, a web search to identify the structure types unique to the country. Here we've sourced some engineering journals, WHE reports, seismic vulnerability assessments, countrywide risk assessments, and other reports. What these do is they give us a general overview of some of the predominant structural types within the given country. So to identify the other structural types not found within the web search, we turn to census data. Two examples are shown here. The first is from the page database, which identifies distributions for 4 different occupancies. They list rural residential, rural non-residential, urban residential, and urban non-residential. As you can see, the information is a little limited with only 4 construction types identified. The second is from a housing census data, which ultimately breaks out wall, roof, and flooring materials for urban and rural regions. We ultimately use these as a starting point for the creation of the mapping schemes. But first we'll need to map the census descriptions to a taxonomy we can use for vulnerability modeling. Based on the research we previously done, we know what types of material systems to expect. Therefore, we can assign a best fit structural type, which is shown in the last table on the right. Example, when the census lists brick as a wall material, we can differentiate whether they mean sun-dried, fire brick, concrete block, or other masonry types based on what we had previously looked up. So here we just show some ground photos through user submitted and our street view, just to verify that our structural assumptions in the previous slides are correct. For Bangladesh in particular, we identified 6 unique development patterns, which can be seen here: rural, primarily single-family residential, high-density residential, urban, high urban, and industrial regions. A satellite image of each development pattern can be found on the right-hand side. So to develop the distribution of structural types for each development pattern, we use resources previously discussed. Mapping schemes for 2 of the development patterns, the rural and urban, have already been established through the housing census data. These percentage checked through visual observation of satellite imagery and ground photos, basically check to see if these make sense. For single-family residential development patterns, we worked off the rural mapping schemes and adjusted the distributions as we saw fit. For example, we observe a fairly significant increase in concrete with masonry infill homes, and a decrease in the more traditional construction methodologies such as wood framed, mud, and formal construction. We observe these changes through visual inspection of satellite imagery. We take note of things such as the types, colors, and shapes of the roof, and what structural type we can expect given these observations. We observe the size of the building footprint, which generally increased from rural to single-family residential, and take note of what structural types to expect for the increase in size. We then verify our assumptions with imagery found in geotagged photos or street view imagery, and we then adjust the percentage breakouts of the rural mapping schemes based on these observations for the single-family development pattern. For high-density residential, urban, and high urban development patterns, we first evaluate the height profiles. We observe predominantly low-rise structures in high-density residential regions, low to mid-rise structures in urban regions, and mid to high structures in the high urban regions. And these height profiles are pretty typical for most countries around the globe. Using these height profiles, we can start making assumptions regarding the particular structural types. For example, for mid to high-rise structures, we can assume traditional techniques using local materials are no longer present and have been replaced by things such as concrete frame, UR and fill, or perhaps engineered reinforced concrete frames or shear walls. For low-rise structures, similar to rural and single-family development patterns, we observe the roof and building footprint characteristics and verify those assumptions with ground imagery. For Bangladesh, we observed a mix between fire brick masonry with masonry infill and some informal construction that in the high density residential areas. For each development pattern, we adjust the percentages based on all these observations. For the industrial development patterns, we first observed the height profile, which was almost exclusively low-rise. We then determine the footprint profiles within the development pattern. For example, is it predominantly open warehouses with large footprints, or is it few warehouses with supporting offices? We observed a mix of both for Bangladesh. We then use the ground imagery to determine which structural system is common for both the warehouse and the surrounding structures, and we calculate our distribution accordingly. So after going through all the processes, we ultimately end up with mapping schemes like the ones shown here on this table. You'll see each development pattern has its own unique set of structural distributions. Once completed, some of the things to ask is if the results make sense. For example, do we see a lessening of traditional techniques the more urban the development pattern gets? Do we see expected height profiles for each development pattern? For example, we expect taller buildings in the central business districts and a gradual decrease the further out you get. Oblique photos such as the ones shown are available and can be a quick check to determine whether the preliminary assessments are reasonable. And we asked, do the mapping schemes represent the built environment throughout the country? For example, is the urban development pattern applicable in all regions? We can then sanity check the results through a sampling strategy for each development pattern. The resultant statistics will confirm whether our initial assumptions are correct or whether they need to be fine-tuned. So, I hope the presentation provided you with a better understanding of the heuristic evaluations of construction patterns for generating level 1 exposure data. In the report, we presented an example for Bangladesh. However, the same processes can be molded to fit really any other country of interest. So thank you for listening, and